Before we begin discussing our next topic, which is Bohr models, I'm going to spend a few minutes just watching some review videos so that we can get refamiliarized with the concept of the periodic table at large. Here we go. So just a quick reminder that the periodic table is divided into groups which are the columns, and periods which are the rows, and that the groups are numbered 1 through 18, and the periods are labeled 1 through 7. Just a quick reminder. Now we're going to watch these videos here, just so we have a brief reminder of what the periods and groups actually mean. Great. So we had a brief reminder of periods and groups and what elements being in specific periods or groups means. Now we're going to watch another video reminding us of what this means for our elements. I apologize. I sneezed and I hit the stop button. Okay, great. So now we have had a quick reminder of how the periodic table is set up, of kind of an introduction into the idea of Bohr models and how valence electrons add up as we move across the table to the right. And then just a very quick reminder of how we find our protons, electrons, and neutrons. Okay, so now let's talk about the purpose of our lesson today. Bohr models. Who remembers this figure? If you've watched a certain Nickelodeon show, it might be kind of familiar to you. Can anybody tell me what they believe this is? Perfect. So this is just a representation of the atom. If you watch Jimmy Neutron, this is the little symbol that is above his head in most of the promotional materials. Okay? So, what are Bohr models? Bohr models are named after Nielsen Bohr, who received the Nobel Prize for discovering that electrons do not just randomly surround the nucleus in what we previously called essentially a sea or cloud of electrons. Bohr's model says that electrons exist in very specific energy levels which surrounds the nucleus, much like our planets exist in very specific places surrounding the sun. So in this example, the nucleus is the sun and the planets are the electrons. Electrons only exist at these specific levels and they do not exist in between. We call these levels shells. Bohr says that electrons will fill the shells nearest to the nucleus first in the following pattern. The first shell can hold 2 electrons. The second shell can hold up to 8 electrons. The third shell can hold up to 18 electrons. The fourth shell can hold up to 32 electrons. However, the outermost shell, the farthest shell on an electron, cannot have more than 8 electrons. It cannot have more than 8 electrons. So even if the fourth shell can hold 32 electrons, if that is the final shell on an atom, it will not hold the full 32. We'll discuss why that is in a second. So just a quick backup. Let's review really quickly. So what is the atomic number for this atom that we see here? This number or this letter in the center tells me what element I'm looking at. What is the atomic number for this element? Perfect. Neon. Neon has an atomic number of 10. So the next question is, how many protons does neon have? Remember the simple trick, atomic number equals protons. So your proton count should also be 10. How many neutrons does neon have? Because I know that neutron's mass number is 20, and I know that to find the neutrons, I just subtract the mass number from the number of protons. That tells me that neon also has 10 neutrons. Okay? Now, the final question. How many electrons does neon have? Again, you should have gotten 10. So we're hitting 4 for 4 with 10. Because the number of electrons in a neutral atom, which is what this is also equal to the number of protons. So now, quick question referring back to what we just learned about these energy levels, which in this image are represented by circles surrounding the nucleus, which is this guy in the middle with the chemical symbol for neon. How many electrons can the first shell hold? Correct. The answer is 2. That means that neon, with 10 total electrons, now has 8 electrons left. So where would we put those 8 electrons? On the next available energy level. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is called Bohr's model of an atom. Here's another handy video on how to draw a Bohr model. And then we'll go ahead and we'll actually do some movement, some video, some work of our own with it. Okay, great. So that was just a great quick example of how we fill Bohr models. Now we're going now we're going to practice doing it ourselves.